Welcome to Dreamy Facts. As the day gently recedes, we invite you to settle into a space of calm contemplation. Tonight, we embark on a journey through Antarctica, exploring approximately 100 fascinating facts that reveal intricate patterns, subtle wisdom, and profound beauty within this enigmatic continent. There is no pressure to remember or retain these details. Instead, let them unfold naturally, inviting your mind to settle into a state of peaceful curiosity. This exploration is designed to be a soothing experience, a gentle current of knowledge flowing without demanding effort or retention. We will observe the intricate dance of ice and life, the subtle adaptations of its resilient inhabitants, and the quiet wisdom embedded in Antarctica's ancient landscapes. Each fact is a small window into the vast and interconnected tapestry of this frozen world, presented in a calm and meditative tone, allowing your thoughts to drift and find stillness. Allow the gentle rhythm of these discoveries to guide you towards a state of relaxation, inviting a sense of wonder and peace as you prepare for rest. Antarctica, a continent of extremes and unparalleled natural majesty, holds secrets that continue to captivate and inspire scientists and dreamers alike. Its stark beauty and profound isolation offer a unique perspective on our planet's history and future. If you're finding peace in this journey, a like and subscribe helps us continue creating these restful explorations. And we're always curious. Share in the comments what city and time zone you're watching from. There's something special about knowing this experience is reaching people all over the world as they prepare for rest. As we begin our exploration, we turn our gaze towards the vast shimmering expanse of Antarctica, a continent cloaked in an icy veil that guards secrets of immense scale and ancient history. This initial journey delves into the sheer magnitude of its ice, the hidden landscapes beneath, and the surprising geological wonders that define this remote land. Let the quiet majesty of these facts wash over you, painting a picture of a world both alien and profoundly part of our own. Antarctica stands as Earth's fifth largest continent, a landmass so vast it is nearly twice the size of Australia. Research shows that this colossal continent is home to the planet's largest single mass of ice, known as the Antarctic ice sheet, which blankets approximately 98% of its surface. This immense ice sheet holds an astonishing 90% of the world's ice, and, consequently, about 70% of its fresh water, an unfathomable reservoir locked away in crystalline form. Scientists have observed that Antarctica maintains the highest average elevation of all continents, primarily due to this massive accumulation of ice. Unlike any other continent, Antarctica has no indigenous human population, its extreme conditions making permanent settlement historically impossible. Its profound isolation contributes to its pristine state, largely untouched by human development, and it remains the only continent without a defined time zone, as research stations often observe the time zone of their home country, or simply local time. This unique combination of scale and remoteness creates a singular environment on Earth. Beneath Antarctica's vast ice sheet, a landscape of mountains, valleys, and even liquid lakes lies hidden, sculpted by ancient forces and preserved by the overlying ice. Studies indicate that the Transantarctic Mountains, one of the longest mountain ranges on Earth, traverse the entire continent, a significant geological feature largely obscured from view. Further inland, researchers have discovered the Gamburtsev Mountains, a range entirely buried under ice, whose peaks and valleys rival the scale of the European Alps. Perhaps most intriguing are the hundreds of subglacial lakes that have been identified, some of which have been completely isolated from the surface for millions of years, potentially harbouring unique forms of life. Lake Vostok, the largest of these subglacial lakes, lies beneath 3.7 kilometres, 2.3 miles of ice, and has been a subject of intense scientific curiosity due to its extreme environment and potential for ancient microbial ecosystems. The average thickness of the Antarctic ice sheet is approximately 1.9 kilometres, 1.2 miles, but in some areas it can reach over 4.7 kilometres, 3 miles, concealing these incredible topographical features beneath its immense weight. Despite being surrounded by vast oceans and covered by ice, Antarctica holds the distinction of being the driest desert on Earth. The continent's interior, particularly the McMurdo Dry Valleys, is essentially ice-free and experiences extremely arid conditions. Research shows that annual precipitation in these areas can be incredibly low, sometimes less than 50 millimeters, 2 inches per year, making them more arid than the Sahara Desert. Along the coast, precipitation is slightly higher, but still averages only around 200 millimeters, 8 inches, of water equivalent annually. The extreme cold causes moisture in the air to freeze out, leading to very low humidity. Powerful katabatic winds, which are gravity-driven winds flowing downhill from the high interior plateau, sweep across the continent, evaporating any surface moisture and contributing significantly to the extreme aridity. This combination of cold, low precipitation, and relentless winds creates an environment so dry that it supports very little vegetation, primarily lichens and mosses in more sheltered areas. Antarctica's geology is as unique as its climate, featuring formations that tell tales of deep time and dynamic planetary processes. Mount Erebus, located on Ross Island, stands as the southernmost active volcano on Earth, constantly emitting steam and gas, and uniquely expelling crystals of feldspar. Another striking phenomenon is blood falls, an outflow of iron-rich salt water from the snout of the Taylor Glacier onto the ice-covered surface of Westlake Bonny, staining the ice a deep, rusty red. This natural wonder is a testament to the complex subglacial hydrology. Scientists have discovered extensive coal deposits within Antarctica, particularly in the Transantarctic Mountains, providing compelling evidence that the continent once supported lush forests and experienced a much warmer climate before its drift to the South Pole. Fossil records also reveal the presence of ancient forests and even dinosaur remains, further cementing its dramatic geological past. The Ellsworth Mountains, home to Mount Vinson, the continent's highest peak, represent another significant geological feature, rising dramatically from the ice sheet. Far from being a static block of ice, Antarctica harbours a dynamic and intricate subglacial hydrological system, a network of rivers and lakes flowing beneath its frozen surface. Research indicates that hundreds of liquid water bodies exist beneath the ice sheet, some of which are interconnected, forming vast subglacial river systems. Scientists have observed that the movement of water within this system can influence the dynamics of the overlying ice sheet, potentially lubricating its base and affecting ice flow rates towards the ocean. Recent explorations of subglacial lakes like Lake Mercer and Lake Whillans have yielded fascinating discoveries, revealing the presence of microbial life that has adapted to these extreme, lightless, and high-pressure environments, potentially isolated for millions of years. These subglacial lakes are not static, but are dynamic systems that can drain and refill, sometimes rapidly, creating significant changes in ice sheet elevation. The discovery and ongoing study of these hidden aquatic worlds continue to reshape our understanding of Antarctica's complexity and its role in global climate systems. As we gently drift through these initial insights, we begin to appreciate the immense scale and hidden vitality of Antarctica, a continent where ice conceals wonders and shapes a truly unique environment. Each layer of ice, each geological feature, tells a part of its profound story, inviting us to look deeper into its mysteries. As we gently drift further into the serene expanse of Antarctica, our journey of discovery continues, moving beyond the immense ice sheets and hidden subglacial worlds to explore the very breadth of this extraordinary continent. We invite you to settle deeper into tranquility, allowing the quiet wisdom of this frozen realm to wash over you, revealing even more profound mysteries that lie just beneath the surface of common knowledge. We have touched upon the McMurdo Dry Valleys as Earth's driest desert, but the atmospheric narrative of Antarctica is far richer, far more intricate. It is a symphony of extremes, where the air itself becomes a canvas for unparalleled phenomena. Imagine, if you will, a place where the air is so pure, so devoid of pollutants, that it is considered the cleanest on Earth. This pristine atmosphere, a testament to its isolation and lack of industrial activity, offers a unique window into our planet's natural systems, a baseline against which global changes can be measured. We find solace in knowing such purity still exists, a gentle reminder of what our world can be, and within this pure air, the cold itself orchestrates wonders. We speak not merely of cold, but of an intensity that redefines the very concept. At the Russian Vostok station, nestled deep within the East Antarctic ice sheet, the mercury has plummeted to an astonishing 128.6 degrees Fahrenheit, 89.2 degrees Celsius. This is not just a record, it is a gateway into understanding the very limits of terrestrial endurance. What makes this particular location so extraordinarily frigid? We learn that Vostok sits upon a high plateau, far from the moderating influence of the ocean, and its elevation allows for a phenomenon known as radiative cooling, where heat efficiently escapes into space from the vast clear skies. The air, heavy and dense, settles into this basin, creating a permanent pool of extreme cold. It is a quiet, relentless chill that shapes everything, from the landscape to the very air we imagine breathing. Yet this profound cold also paints the sky with ethereal beauty. Have you ever considered the dance of light in an atmosphere so crystalline? We invite you to witness, in your mind's eye, the mesmerizing spectacle of the Antarctic aurora. Unlike its northern counterpart, the aurora australis often appears in shades of pink and green, shimmering and swirling across the polar night, a celestial ballet caused by solar particles colliding with Earth's magnetic field. It is a vision of otherworldly grace, a vibrant reminder of the powerful forces at play in our universe. Beyond the auroras, the cold air itself becomes an artist. We observe the phenomenon of diamond dust, tiny ice crystals suspended in the air, reflecting sunlight to create dazzling optical effects. These can manifest as sundogs, parhelia, luminous halos around the sun or moon, and even light pillars stretching vertically into the sky. These are not mere illusions. They are tangible expressions of the extreme conditions, transforming the very light into intricate fleeting sculptures. The air, seemingly empty, is alive with these sparkling fragments, a constant silent shower of frozen light. It is in these moments that we truly grasp the profound beauty born of extreme conditions, a quiet testament to the continent's unique atmospheric alchemy. As we delve deeper, we encounter life itself, not merely surviving but thriving in this seemingly inhospitable environment, demonstrating an astonishing capacity for adaptation. Our previous contemplations revealed microbial life hidden beneath ancient ice, but the resilience extends far beyond these secluded aquatic realms. We now turn our gaze to the more visible, yet equally miraculous forms of life that call Antarctica home, both on its icy surface and within its frigid waters. Consider the Antarctic fish, for instance. How do they navigate waters that consistently hover around the freezing point of fresh water, sometimes even dropping below it due to the salinity? We discover a fascinating biological marvel. These fish possess natural, quote 2, proteins in their blood. These glycoproteins bind to tiny ice crystals, preventing them from growing larger and fatally freezing the fish's cells. It is an elegant, intricate solution, a biochemical shield against the relentless cold, allowing life to persist where it otherwise could not. This adaptation is a quiet testament to evolution's ingenuity, a subtle yet profound victory over the harshest conditions. And then there are the microscopic wonders that adorn the very snow and ice. We invite you to imagine the vibrant phenomenon of ruand, quote thirsta. During the warmer Antarctic summer, vast expanses of snow can take on a striking pink or reddish hue. This is caused by various species of cold-loving algae, particularly Chlamydomonas nivalis, which contain a red pigment called astaxanthin to protect themselves from intense UV radiation. These tiny organisms, invisible to the naked eye individually, collectively transform the pristine white landscape into a living, breathing canvas of surprising colour. It is a reminder that even in the most barren-seeming landscapes, life finds a way to flourish, adding unexpected splashes of vitality. Beyond the algae, we encounter creatures of even greater resilience, the tardigrades, or, quote, these microscopic invertebrates are legendary for their ability to survive extreme conditions, and Antarctica is one of their natural strongholds. We learn that tardigrades can enter a state of suspended animation known as cryptobiosis, allowing them to withstand desiccation, radiation, extreme temperatures, and even the vacuum of space. They can literally dry out, shrink into a tiny ball, and remain in this state for decades, only to reanimate when conditions become favourable again. In Antarctica, they can be found in mosses and lichens, patiently awaiting the brief moments of meltwater that allow them to stir back to life. Their existence is a profound lesson in endurance, a quiet affirmation of life's indomitable spirit. The marine ecosystem surrounding Antarctica is also a marvel of specialized adaptations, forming a food web of astonishing efficiency. At its heart lies Antarctic krill, Eupausia superba, tiny crustaceans that form the largest single-species biomass on Earth. We learn that these shrimp-like creatures are the primary food source for almost all other Antarctic animals. Whales, seals, penguins, and seabirds depend on them. Krill themselves feed on phytoplankton, which flourish in the nutrient-rich cold waters. The sheer abundance of krill, a staggering estimated 500 million tons, supports a complex and dynamic ecosystem. It is a powerful illustration of how a single species can underpin an entire biome, a delicate balance sustained by the unique conditions of the Southern Ocean. The entire web of life here, from the microscopic algae to the colossal blue whales, is intricately woven, each thread dependent on the other, each adapted to the chilling embrace of this polar world. Our journey through Antarctica's present wonders now invites us to look back, deep into the annals of geological time, and outward into the vastness of the cosmos. For Antarctica is not only a continent of contemporary marvels, but also a profound repository of Earth's ancient past, and a silent collector of extraterrestrial secrets. We have previously touched upon the coal and fossil deposits, hinting at a dramatically warmer past, a time when lush forests and dinosaurs roamed this land. To truly grasp this transformation, we contemplate Antarctica's origins as a central piece of the supercontinent Gondwana. We understand that over hundreds of millions of years, tectonic forces slowly fractured Gondwana, sending continents drifting to their present positions. Antarctica, once connected to Australia, India, Africa, and South America, gradually moved south, its climate cooling as it became isolated by the circumpolar current. This slow, deliberate dance of tectonic plates sculpted its destiny, transforming a verdant land into the icebound continent we know today. It is a testament to the immense power and patience of geological processes, a quiet narrative of continental drift unfolding across eons. And within this ancient landscape, Antarctica holds a unique allure for scientists studying objects from beyond our world. We learn that it is the best place on Earth to find meteorites. Why is this so? The vast, white expanse of the ice sheet acts as a giant, pristine collecting plate. Meteorites that fall here are preserved by the dry, cold conditions, preventing weathering and contamination. Furthermore, the slow movement of the ice sheets often brings these extraterrestrial fragments to the surface at specific, quote, fairfax, where glaciers encounter obstacles like mountains, causing the ice to ablate, evaporate, leaving the darker meteorites exposed against the white backdrop. Each meteorite found is a silent messenger from space, offering clues about the formation of our solar system, the composition of asteroids, and even the potential for life beyond Earth. We are reminded that Antarctica is not just a part of our planet. It is a cosmic archive, holding fragments of stardust and the origins of everything we know. Beyond these cosmic visitors, the continent's geology continues to surprise. Beneath the overwhelming ice, we find evidence of active geothermal heating in unexpected places beyond just Mount Erebus. We discover that certain regions exhibit higher than average heat flow from the Earth's interior, influencing subglacial lake formation and even ice sheet dynamics. This internal warmth, a subtle pulse from deep within the Earth, creates hidden melt zones and influences the flow of vast ice streams. It is a reminder that even beneath miles of ice, our planet remains a dynamic, living entity, its internal processes subtly shaping the surface world. As we conclude this chapter, we find ourselves enveloped in a deeper understanding of Antarctica's profound interconnectedness, from the purity of its air to the resilience of its life, and from its ancient geological past to the cosmic dust it collects. We have merely scraped the surface of its wonders, yet each fact, each observation, paints a richer, more vibrant picture. We invite you to carry these images with you, letting them settle into your consciousness, preparing for further revelations. The journey into the heart of this majestic continent continues, promising even more untold stories and quiet wisdom that await your gentle contemplation. As we gently drift deeper into the heart of this majestic continent, propelled by the quiet wisdom gleaned from its hidden geothermal warmth, we begin to perceive a grander narrative unfolding. The vitality beneath the ice, a testament to Earth's enduring power, is but one thread in the intricate tapestry of Antarctica's profound existence. It is a land not just of geological marvels and extreme conditions, but also a crucible for life, a regulator of our planet's climate, and a beacon for humanity's collective scientific endeavour. You might wonder how such a vast, resource-rich land, devoid of indigenous human populations, is managed. Here, in this realm of pristine ice and staggering beauty, humanity has forged an unprecedented agreement. Antarctica stands as the only continent on Earth without a native human population, a silent sentinel in the Southern Ocean. Its destiny, however, is not left to chance or singular ambition. We find, instead, a remarkable testament to international cooperation: the Antarctic Treaty System. Imagine, if you will, a continent dedicated solely to peace and scientific research, where national claims are held in abeyance and military activity is strictly forbidden. This visionary framework, established in 1959, transforms Antarctica into a global laboratory, a natural reserve where the pursuit of knowledge transcends geopolitical divides. We invite you to consider the profundity of this arrangement. A vast land mass, larger than Europe, where the only flags flown are those of scientific collaboration, where the only battles waged are against the elements, and the only conquests are those of understanding. Under the treaty, environmental protection protocols are stringently observed, ensuring that our human footprint remains as light as a snowflake upon the ancient ice. Every expedition, every research station, every human presence is governed by a shared commitment to preserve this unique wilderness for future generations. It is a living example of what we, as a global community, can achieve when we prioritize the planet's health and the advancement of knowledge above all else. This quiet diplomacy, this shared guardianship, imbues Antarctica with a serene aura, a sense of collective responsibility that resonates across the icy plains. Our journey now carries us to the shores and icy waters, where life, in its myriad forms, has sculpted remarkable adaptations to thrive in this seemingly inhospitable environment. While we have marvelled at the resilience of krill and the antifreeze marvels of fish, the Antarctic ecosystem pulses with a vibrant diversity, a testament to evolution's ingenious designs. As we approach the rugged coastlines, you will undoubtedly be greeted by the continent's most iconic inhabitants, the penguins. Antarctica is home to several species, each a marvel of avian engineering. The majestic emperor penguin, a true titan of the ice, endures the harshest winters, huddling in vast colonies to protect its precious offspring from the biting winds and unimaginable cold. Their elegant torpedo-like bodies are perfectly adapted for diving to incredible depths in pursuit of fish and krill. Their wings transformed into powerful flippers, propelling them through the frigid waters with effortless grace. Then there are the bustling Adelie penguins, their tuxedo-like appearance a charming contrast to the stark white landscape, tirelessly building nests from pebbles. We also encounter the spirited chinstrap penguins, named for the slender black line beneath their beaks, and the curious gentoo penguins, recognizable by the white patch above their eyes and their distinctive trumpeting calls. Each species, with its unique behaviors and survival strategies, paints a vivid picture of life's tenacity at the edge of the world. Beneath the waves and upon the ice floes, a diverse array of seals finds its sanctuary. The gentle Weddell seal, often found resting near breathing holes it maintains in the thick ice with its robust canines, can dive for extended periods, its blood uniquely adapted to store oxygen. The more elusive Ross seal, with its distinctively large eyes, glides through the pack ice while the vast populations of crabita seals, despite their name, primarily feast on krill, their specialized teeth acting as sieves. And let us not forget the powerful leopard seal, a formidable predator of penguins and other seals, its sleek form a testament to its aquatic prowess. Each seal, a testament to specialized evolution, plays a vital role in the intricate food web of the Southern Ocean. The very air, too, carries the breath of giants. The nutrient-rich waters surrounding Antarctica attract an astonishing number of whales, migrating here to feast on the abundance of krill during the summer months. You might witness the awe-inspiring sight of a blue whale, the largest animal on Earth, gliding through the icy waters, or the acrobatic displays of humpback whales breaching against the backdrop of towering icebergs. Fin whales, minke whales, and the intelligent orcas, often called killer whales, also grace these waters, their presence a powerful reminder of the ocean's boundless energy and the profound interconnectedness of life. Yet, life here also takes on miniature forms, often overlooked but no less extraordinary. The largest strictly terrestrial animal on the continent is not a mammal or a bird, but an insect, the Antarctic midge, Belgica antarctica. This tiny wingless fly, measuring only a few millimeters, is a marvel of adaptation, capable of surviving repeated freezing and thawing, enduring extreme dehydration, and existing solely on the continent. Its very existence defies the common perception of Antarctica as utterly barren, and in the more sheltered, ice-free coastal areas, we find hardy plant life. Resilient mosses and lichens cling to rocks, and in a few rare spots 2 flowering plants, the Antarctic hairgrass and the Antarctic pearlwort, bravely unfurl their delicate forms, a splash of green against the dominant white. These small, often unseen wonders remind us that even in the harshest environments, life finds a way to persist, to flourish, and to inspire. Our journey now takes a broader view, stretching beyond the immediate landscapes to encompass Antarctica's profound influence on the entire planet. This frozen continent, seemingly isolated, is in fact a pivotal orchestrator of global climate and ocean dynamics. We invite you to contemplate its immense power, its quiet regulation of our shared world. At its heart lies the colossal Antarctic Circumpolar Current, ACC, the largest ocean current on Earth. Imagine a vast, unbroken river of water, hundreds of kilometers wide and thousands of meters deep, perpetually circling Antarctica, driven by powerful westerly winds. This mighty current connects the Atlantic, Pacific, and Indian Oceans, effectively isolating Antarctica both climatically and biologically. It acts as a formidable barrier, preventing warmer waters from reaching the continent's icy shores, thus maintaining its frigid conditions. Without the ACC, Antarctica's climate would be vastly different, and with it, the global climate. Antarctica itself plays a critical role in global climate regulation, often referred to as Earth's cold sink. Its immense ice sheet, a shimmering expanse of white, possesses a high albedo, meaning it reflects a significant portion of the sun's radiation back into space. This reflective power helps to cool the planet, counteracting the absorption of solar energy that occurs in darker regions. As we contemplate the delicate balance of Earth's climate, we recognize Antarctica as a crucial component, a vast white mirror maintaining planetary equilibrium. The sheer volume of ice locked within this continent also holds the key to global sea levels. Should even a fraction of the Antarctic ice sheet melt, the implications for coastal communities worldwide would be profound. The stability of this frozen reservoir is therefore a matter of global concern, a constant subject of scientific scrutiny as we seek to understand the delicate interplay between ice, ocean, and atmosphere. Furthermore, the frigid waters surrounding Antarctica are the birthplace of deep ocean water formation, a fundamental driver of global ocean circulation, the thermohaline circulation, or the global conveyor belt. As sea ice forms, it expels salt, making the remaining seawater denser and colder. This dense water sinks to the ocean floor, flowing northward and carrying oxygen and nutrients to the deep ocean basins around the world. This process is a vital component of Earth's climate system, influencing marine ecosystems and the distribution of heat across the globe. Antarctica, in its quiet grandeur, thus acts as a vital pump, circulating lifeblood through the planet's vast oceanic arteries. As we continue our exploration, we are continually struck by the sheer, overwhelming scale of Antarctica, a continent that defies easy comprehension. Its immensity whispers of ancient times, of geological forces that have shaped its hidden depths and towering peaks. Consider its size. Antarctica is not merely a large island, but a continent vaster than you might imagine, larger than Europe and nearly double the size of Australia. This immense landmass is almost entirely shrouded in ice, an average of about 1 mile, 1.6 kilometers, thick. Yet, in certain regions, such as the Wilkes-Land Basin, the ice can reach an astonishing thickness of over 3 miles, 4.8 kilometers, pressing down on the ancient bedrock with unimaginable weight. To stand upon this ice is to stand atop a mountain range, a landscape carved not by wind and water, but by the relentless accumulation of millennia of snow. Beneath this colossal ice sheet lies a rugged and complex topography, a testament to the continent's dynamic geological past. Far from being a flat, featureless plain, Antarctica is tectonically active, concealing several mountain ranges. We have already glimpsed the Gamburtsev Mountains, hidden beneath miles of ice, a range rivaling the Alps in grandeur. And rising majestically above the ice in West Antarctica are the Ellsworth Mountains, home to Vinson Massif, the continent's highest peak, reaching an elevation of 16,050 feet, 4,092 meters. These exposed peaks offer a glimpse into the underlying geology, revealing the continent's ancient origins. A fascinating geographical nuance awaits us at the very bottom of the world. The geographical South Pole. Itself, the Earth's southernmost point of axis, is not a fixed point on a stationary landmass. Rather, the massive ice sheet covering it is in constant, albeit slow, motion. This means that the markers placed to denote the South Pole must be periodically relocated to account for the ice's movement, a subtle reminder of the continent's dynamic nature, even at its most defined point. This slow, majestic drift of the ice over the geographical pole evokes a sense of deep time, where human markers are but fleeting gestures against the backdrop of geological eternity. Our journey would be incomplete without acknowledging the extraordinary human spirit that dares to venture into this sublime wilderness. Despite its formidable challenges, Antarctica has become a vibrant hub for international scientific research, a testament to humanity's unquenchable thirst for knowledge. Across the continent, over 70 research stations are operated by various countries, though not all maintain a year-round presence. These outposts of human ingenuity are scattered from the coastal fringes to the deep interior, each a beacon of scientific inquiry. Among the most renowned is the Amundsen Scott South Pole Station, situated directly at the geographical South Pole. Imagine living and working in one of the most remote and extreme locations on Earth, where the sun rises and sets only once a year, and temperatures plummet to unimaginable lows. Life at these stations, particularly during the long dark winter months, presents unique challenges. Winter overpopulations can be incredibly small, sometimes just a dozen or so individuals, leading to a profound sense of isolation and a reliance on close-knit community. The psychological resilience required to endure months of darkness, extreme cold, and separation from the familiar world is immense, fostering a unique camaraderie among those who brave the Antarctic winter. The research conducted here is as diverse as the continent itself. Glaciologists study the dynamics of the ice sheet, unraveling its past and predicting its future. Oceanographers explore the mysteries of the Southern Ocean, its currents, and its unique marine life. Astrophysicists gaze skyward, utilizing the pristine dark skies and thin atmosphere for observatories like the Ice Cube Neutrino Observatory, searching for the most elusive particles in the universe. Biologists delve into the incredible adaptations of Antarctic life, while atmospheric scientists monitor the planet's climate and ozone layer. Every aspect of life at these stations, from construction to daily sustenance, is an exercise in extreme engineering and logistics. Everything, from building materials to fresh food, must be meticulously transported across vast distances, and just as carefully, all waste must be removed, upholding the strict environmental protocols that protect this pristine environment. These human endeavours, these outposts of scientific dedication, are a humble yet powerful presence in the vastness of Antarctica, a bridge between the ancient ice and the frontiers of human understanding. Their quiet work ensures that the mysteries of this continent continue to unfold, inviting us with every discovery to deepen our appreciation for Earth's most enigmatic and vital realm. As we drift further into the quiet wisdom of Antarctica, having traversed its vast icy plains and plumbed the depths of its hidden waters, we now turn our gaze to a different kind of story, the human story. It is a narrative etched not in ice, but in the annals of courage, scientific endeavour, and an unprecedented spirit of international cooperation. For centuries this continent remained an enigma, a fabled terra australis incognita, until the intrepid spirit of humanity began to chip away at its icy veil, revealing its profound secrets. Long before satellites mapped its contours and sophisticated instruments measured its pulse, Antarctica beckoned to a select few, drawing them with the irresistible allure of the unknown. We journey back to an era when maps ended abruptly at the edge of the known world, and the Southern Ocean was a realm of myth and peril. The first confirmed sightings and landings in the early 19th century, by figures like Bellingshausen, Bransfield and Palmer, were mere whispers of what lay beyond, fleeting glimpses of a continent shrouded in mist and ice. These were the audacious pioneers sailing into the teeth of unimaginable storms, their wooden vessels dwarfed by towering icebergs, their very existence a testament to human resilience. It was the, quote, gestalt of Antarctic exploration, spanning the late 19th and early 20th centuries, that truly etched the continent into the human consciousness. Names like Scott, Shackleton and Amundsen became synonymous with epic struggles against nature's fiercest elements. We recall their arduous journeys across treacherous ice, their battles against frostbite, starvation, and the crushing weight of isolation. Imagine, if you will, the sheer willpower required to drag heavy sledges across an endless white expanse, the horizon an unbroken line of blinding white, the silence so profound it seemed to amplify the beating of one's own heart. Sir Ernest Shackleton's imperial trans-Antarctic expedition, though it failed to cross the continent, became a legendary tale of survival against impossible odds. His crew, marooned for months on drifting ice, their ship, Endurance, crushed, endured unimaginable hardship, yet every single man was brought home alive, a feat of leadership and sheer human spirit that continues to inspire. Then there was the dramatic race to the South Pole, a contest between Robert Falcon Scott and Roald Amundsen, a tale of triumph and tragedy that underscores both the grandeur and the brutal indifference of this frozen realm. Amundsen, with his meticulous planning and mastery of polar travel techniques, reached the pole first on December 14th, 1911. Scott and his team arrived a month later, only to perish on their return journey, victims of extreme weather and exhaustion. These early explorers did not merely chart new territories, they expanded the boundaries of human endurance and deepened our understanding of the planet's most extreme environment. Their legacy is not just one of discovery, but of profound respect for the power and mystery of Antarctica. From the precarious camps of early explorers, Antarctica has evolved into a global sanctuary for scientific inquiry, dotted with over 70 research stations operated by various nations. These outposts, from the remote Amundsen Scott South Pole Station, perched directly atop the geographical South Pole, to coastal havens like McMurdo Station, are vibrant hubs of international collaboration. Here, scientists from diverse backgrounds converge, their shared purpose transcending national borders, united by the common goal of unravelling Antarctica's secrets. Life at these stations is a unique blend of cutting-edge research and extreme isolation. Imagine a community where your nearest neighbour might be hundreds of miles away, where daylight can last for months, followed by an equally long period of perpetual darkness. The challenges are immense. Brutal winds, temperatures that plunge far below zero, and the constant logistical puzzle of resupplying remote locations. Yet, within these resilient communities, a unique culture flourishes, one of camaraderie, resourcefulness, and a profound appreciation for the stark beauty of their surroundings. We find scientists, engineers, cooks, medics, and support staff, all playing crucial roles in maintaining these vital outposts of knowledge. The pristine environment of Antarctica offers unparalleled conditions for a myriad of scientific disciplines, pushing the boundaries of human understanding in ways few other places on Earth can. Astrophysics and the Ice Cube Neutrino Observatory. Beneath the surface of the South Pole, a colossal telescope lies buried within a cubic kilometre of ice. This is the Ice Cube Neutrino Observatory, a marvel of engineering designed to detect high-energy neutrinos, ghostly subatomic particles that stream through space, carrying information about the most violent events in the universe, such as exploding stars and black holes. Antarctica's deep, clear, and stable ice provides the perfect medium for this unique observatory, shielding it from cosmic rays and other interference, allowing us to peer into the farthest reaches of the cosmos. Imagine the quiet hum of advanced technology beneath miles of ancient ice, listening for whispers from distant galaxies, helping us understand the origins of the universe itself. Glaciology and ice core drilling. Perhaps one of the most compelling scientific endeavours in Antarctica is the drilling of ice cores. Picture immense drills boring down thousands of feet into the ice sheet, extracting cylinders of compressed snow and ice, each ring a frozen archive of Earth's past. These ice cores are like frozen time capsules, preserving ancient air bubbles, volcanic ash, and even microscopic dust. By analysing these samples, glaciologists can reconstruct Earth's climate history over hundreds of thousands, even millions of years. We learn about past atmospheric compositions, temperature fluctuations, and the natural cycles that have shaped our planet long before human influence. These cores provide invaluable context for understanding current climate change, revealing the unprecedented speed and scale of present-day warming trends. Paleontology and ancient ecosystems. While today Antarctica is a realm of ice, its geological history reveals a surprisingly different past. The discovery of dinosaur fossils, including species like Cryolophosaurus eleotis in the Transantarctic mountains, paints a vivid picture of a once verdant continent. These findings, along with the extensive coal deposits we mentioned earlier, confirm that Antarctica was once part of the supercontinent Gondwana, hosting lush forests and diverse ecosystems. Imagine a tropical Antarctica, teeming with life, a stark contrast to its current frozen state. These paleontological treasures offer crucial insights into continental drift, ancient biogeography, and the incredible resilience and adaptability of life on Earth. Oceanography in the Southern Ocean. Surrounding Antarctica is the Southern Ocean, a dynamic and critically important body of water. Here, oceanographers study the Antarctic Circumpolar Current, ACC, the world's largest ocean current, which plays a vital role in global ocean circulation and heat distribution. They investigate the intricate food web, from the foundational krill to the majestic whales, and monitor the impacts of climate change on marine ecosystems. The Southern Ocean acts as a significant GSM, quote 9, absorbing vast amounts of atmospheric carbon dioxide, making its health crucial for the entire planet. Research here helps us understand ocean acidification, sea ice dynamics, and the complex interplay between the ocean, atmosphere, and ice sheets. Life in Antarctica demands extraordinary adaptation, not just from its wildlife, but from its human inhabitants too. Beyond the scientific pursuits, daily life at these stations is a testament to human ingenuity and camaraderie. The coldest marathon. For those seeking the ultimate test of endurance, Antarctica offers the unique challenge of the Antarctic Ice Marathon, the southernmost marathon on Earth. Participants brave sub-zero temperatures, icy winds, and soft snow underfoot, pushing their physical and mental limits in a landscape of unparalleled beauty and brutal indifference. It is a powerful symbol of the human drive to explore and conquer, not just external frontiers, but also the boundaries of personal capability. A world without time zones, mostly. Given its unique position at the South Pole where all lines of longitude converge, Antarctica technically has no official time zones. However, research stations typically adopt the time zone of their home country or their primary supply base. This creates a fascinating mosaic of time across the continent, where different stations operate on different schedules, a subtle reminder of the international presence and the shared, yet individually managed human experience. The art of resourcefulness. With everything needing to be flown or shipped in, and nothing allowed to be left behind, resourcefulness is paramount. Waste is meticulously managed. Water is often produced from melting snow, and energy conservation is a way of life. Imagine a place where every item, from a spare screw to a fresh vegetable, is precious and carefully accounted for. This culture of sustainability and careful management offers valuable lessons for the rest of the world. The presence of humanity in Antarctica, while driven by discovery, is governed by an unparalleled commitment to environmental protection. The Antarctic Treaty System, which we previously explored, stands as a beacon of international cooperation, designating the continent solely for peaceful purposes and scientific research. This unique agreement ensures that Antarctica remains a natural reserve, a pristine laboratory for understanding our planet. However, even this remote sanctuary faces challenges. The warming climate is causing parts of the Antarctic ice sheet, particularly the vulnerable West Antarctic ice sheet, to melt at an accelerated rate, contributing to global sea level rise. Ocean acidification threatens the krill populations, which form the base of the entire Antarctic marine food web. We are vigilant, monitoring these changes, as Antarctica serves as a critical barometer for the health of our global climate. Tourism, while carefully regulated, also presents a delicate balance. Visitors are drawn by the continent's majestic beauty and unique wildlife, but strict guidelines are in place to minimize impact, ensuring that the footprint of human presence remains as light as possible. Every visitor, every scientist, every support staff member becomes a custodian of this fragile ecosystem. As we conclude this chapter, reflecting on the human footprint in Antarctica, we are left with a profound sense of awe, not only for the continent itself, but for the human spirit that has dared to explore it, to study it, and to protect it. The echoes of early explorers, the quiet dedication of scientists, and the global commitment to preservation all intertwine to form a narrative of hopeful guardianship. Antarctica, in its majestic silence, reminds us of our planet's grandeur and our shared responsibility to safeguard its wild, mysterious heart. Our journey continues, ever deeper into the heart of this frozen wonder, revealing more facts you've never heard and inspiring a quiet reverence for the world we inhabit. As we journey deeper into the heart of Antarctica's mysteries, we find ourselves at a crucial juncture, where the ancient echoes of its past meet the urgent whispers of its future. This majestic continent, a sentinel of global climate, now reveals itself as a dynamic canvas where profound changes are underway, changes that resonate far beyond its icy shores. We invite you to contemplate the intricate dance between ice, ocean, and atmosphere, and the dedicated efforts to understand a future that is, in many ways, already unfolding. The serene stillness of Antarctica belies a powerful transformation, particularly within its vast ice sheets. We've spoken of its immense ice reserves, but let us now consider the sheer scale of what is at stake. The West Antarctic ice sheet, WAIS, for instance, holds enough water to raise global sea levels by approximately 3.3 meters, or nearly 11 feet, were it to melt entirely. This is not a distant fantasy, but a subject of intense scientific scrutiny, as observations reveal an accelerating mass loss in key regions. One of the most compelling examples of this dynamic is the Thwaites Glacier, often referred to as the Doomsday Glacier due to its critical role. This colossal river of ice, roughly the size of Florida, alone possesses the potential to raise global sea levels by over 0.5 meter, or 2 feet. More critically, it acts as a linchpin, a natural cork holding back surrounding ice that could contribute several additional meters to sea level rise. Its accelerated retreat is not merely a surface phenomenon. It is driven by processes occurring deep beneath the icy veil. Beneath the colossal weight of the ice, hidden subglacial meltwater rivers carve intricate channels, acting as lubrication between the ice and the bedrock. Research has revealed that these hydrological systems, often unseen, can significantly accelerate the flow of ice towards the ocean, creating pathways for rapid discharge. This internal plumbing system, once thought to be relatively static, is now understood as a dynamic network that responds to both surface melt and geothermal heat. Perhaps even more concerning is the phenomenon of basal melt, where warmer ocean currents erode ice shelves from below. These ice shelves, vast floating extensions of the continental ice sheets, act as crucial buttresses, slowing the flow of inland ice into the ocean. Without these ice shelves, the grounded ice behind them can accelerate dramatically. Studies employing autonomous underwater vehicles, AUVs, have mapped unprecedented rates of basal melt in areas like the Thwaites Glacier, revealing how the ocean's silent embrace is reshaping the very foundations of the continent. The loss of these ice shelves, therefore, is not just a loss of floating ice. It is a trigger for the rapid acceleration of the continental ice itself, a domino effect with global repercussions. To comprehend these monumental shifts, an army of dedicated scientists employs a sophisticated arsenal of tools, transforming the remote Antarctic into a global laboratory. From the serene expanse of space, satellite altimetry missions, like IceSat and CryoSat, meticulously measure changes in ice sheet height with millimeter precision. These orbital sentinels provide an unparalleled overview, revealing areas of mass loss and gain across the entire continent, painting a stark picture of its evolving landscape. Closer to the ice-ocean interface, where the most dramatic changes are often hidden, autonomous underwater vehicles, AUVs, are deployed. These robotic explorers venture into the dark, frigid waters beneath massive ice shelves, mapping the seafloor and measuring ocean conditions where human presence is impossible. They provide crucial data on the interaction between ice and ocean, revealing the pathways of warm water and the dynamics of basal melt, offering insights into processes that were once purely theoretical. On the ice itself, the ancient stories of Earth's climate are preserved in silent layers. Ice cores, painstakingly drilled deep into the ice sheet, offer a historical record of our planet's atmosphere stretching back over 800,000 years. Each layer of ice traps ancient air bubbles, revealing past concentrations of greenhouse gases like CO2 and methane, alongside temperature fluctuations. These frozen archives provide a critical baseline, allowing scientists to contextualize current warming trends against millennia of natural climate variability. They are the Earth's own diary, offering profound insights into the long-term rhythm of our climate. Further beneath the surface, a different kind of tremor speaks of the ice's restless movement. Seismometers, carefully placed on the ice, detect ice quakes, subtle tremors caused by the fracturing and movement of glaciers. These seismic signals provide real-time data on the internal dynamics of the ice, revealing how glaciers respond to changes in temperature and meltwater, offering a granular view of their powerful slow-motion journey towards the sea. And in the vast, swirling waters that embrace the continent, oceanographic moorings are deployed, silently monitoring the Southern Ocean. These submerged sentinels continuously record temperature, salinity, and current velocity, tracking the subtle yet powerful entry of warmer waters into the Antarctic region. This oceanic data is vital for understanding how the ocean's currents are influencing the stability of the ice sheets, completing a complex puzzle that spans from the depths of the ocean to the heights of the atmosphere. Beyond the dramatic narratives of melting ice, a quieter, yet equally profound transformation is underway in the Southern Ocean, a shift that threatens the very foundation of its vibrant ecosystem. The Southern Ocean, with its naturally colder waters, is particularly vulnerable to ocean acidification. Colder waters absorb CO2 more efficiently, and as the atmosphere accumulates more carbon dioxide from human activities, the ocean absorbs a significant portion of it, leading to a decrease in pH. This makes the water more acidic, a change that can have devastating effects on marine life. At the heart of this ecosystem, Antarctic krill, the cornerstone of the Southern Ocean food web, are exquisitely sensitive to changes in ocean pH. These tiny crustaceans, upon which whales, seals, penguins, and countless other species depend, can suffer impaired shell formation and reduced reproductive success in more acidic waters. Imagine a world where the very building blocks of life struggle to form, where the foundational food source for an entire continent begins to falter. Another delicate creature, the pteropod, or quote 12, tiny snails crucial to the food web, are also highly susceptible to acidification. Their delicate calcium carbonate shells, essential for their survival, literally begin to dissolve in increasingly acidic waters. The cascading effects of such changes ripple through the entire food chain, threatening the delicate balance of this pristine environment. Furthermore, changes in sea ice extent, driven by warming temperatures, directly impact krill populations. Sea ice provides vital habitat and a crucial food source for their larval stages, offering protection and sustenance during the harsh Antarctic winter. A reduction in this critical nursery ground can lead to significant declines in krill numbers, exacerbating the challenges posed by ocean acidification. These environmental shifts are already causing observable changes in the distribution and abundance of iconic Antarctic wildlife. While some species, like Ndelli penguins, are experiencing population declines in areas with reduced sea ice, others, such as gentoo penguins, are expanding their ranges southward, adapting to newly accessible ice-free areas. These shifts, while appearing as adaptation for some, underscore the profound reorganization of the ecosystem driven by a changing climate. The urgency of these observations leads us to contemplate the future with a blend of scientific rigor and profound concern. Projections indicate that if current warming trends continue unabated, parts of the West Antarctic ice sheet could reach an irreversible. Quote 13. Within decades to centuries. Beyond this threshold, the ice sheet's collapse could become self-sustaining, leading to unstoppable contributions to global sea level rise, regardless of future emission reductions, a concept known as the marine ice cliff instability. Hypothesis suggests a potential mechanism for such rapid collapse. It posits that once ice shelves retreat past a certain point, exposing tall, unsupported ice cliffs, these cliffs can become inherently unstable and dramatically collapse into the ocean, accelerating the retreat of the entire ice sheet. This scenario, while still being refined by research, paints a stark picture of potential abrupt changes. To better understand these future possibilities, scientists delve into Earth's deep past. Research into past warm periods. In Earth's history, preserved in Antarctic geological records and ice cores, help scientists understand the potential scale and speed of future sea level rise. Ancient shorelines and marine sediments reveal periods when global temperatures were similar to or slightly warmer than today, providing crucial analogues for predicting the long-term consequences of our current trajectory. These echoes from the past serve as potent warnings for the future. Antarctica's melting ice contributes not only to global sea level rise, but also significantly affects global ocean circulation patterns. The influx of vast quantities of fresh, cold meltwater can disrupt the delicate balance of ocean density and salinity, potentially altering major ocean currents that distribute heat around the globe. This could, in turn, influence weather patterns and climates far from the poles, demonstrating once again Antarctica's profound interconnectedness with the entire planet. The continent is not merely a frozen landmass. It is a vital organ in Earth's complex circulatory system, In the face of these immense challenges, the global community's response is both a testament to human ingenuity and a model for future endeavours. International scientific collaboration. On Antarctica, enshrined by the Antarctic Treaty System, serves as a critical blueprint for global cooperation in addressing shared environmental challenges. Nations put aside political differences to unite in a common pursuit of knowledge, recognizing that the fate of this continent affects us all. Behind every satellite image, every ice core and every data point stand the remarkable men and women who dedicate their lives to understanding Antarctica. Scientists working in this extreme environment often endure months of isolation, extreme cold, and hazardous conditions, living in self-sufficient research stations powered by renewable energy or specialized fuels. Their resilience and resourcefulness are as profound as the landscapes they study. Field camps on the ice can be hundreds of miles from the main stations, requiring complex logistics, specialized vehicles, and rigorous safety protocols. Imagine establishing a temporary home in a landscape where temperatures plummet to unimaginable lows, where blizzards can rage for days, and where every piece of equipment must be meticulously maintained. These are not merely scientific outposts, they are beacons of human determination. Many Antarctic research projects are inherently multidisciplinary, involving glaciologists, oceanographers, biologists, atmospheric scientists, and engineers working together in seamless collaboration. The complexity of the Antarctic system demands a holistic approach, where experts from diverse fields combine their knowledge to unravel its intricate secrets. This collaborative spirit is a hallmark of Antarctic science. The data gathered from Antarctica is not confined to individual nations or institutions, it is shared globally. Contributing to major international climate assessments and informing policy decisions worldwide. This open access to scientific findings ensures that our collective understanding of Earth's climate system is continually refined, providing the most accurate information possible for guiding our response to global change. Despite the harshness and the immense challenges, many scientists describe their time in Antarctica as profoundly transformative. It fosters a deep connection to the natural world, an unparalleled sense of awe, and a shared purpose that transcends national boundaries. It is a place where the human spirit is tested, yet often emerges with a renewed sense of responsibility for our planet. A quiet wisdom gleaned from the vast, silent grandeur of the ice. As we conclude this chapter, we leave you with the profound realization that Antarctica is not a distant, static realm, but a living, breathing component of our global ecosystem, intricately linked to our own well-being. Its future is intertwined with ours, and the ongoing scientific vigilance and international cooperation underscore a fundamental truth. The stewardship of this wondrous frozen world is a shared responsibility, a testament to our collective capacity for understanding and protection. The quiet wisdom of the ice continues to call to us, inviting us to listen, learn, and act. As we ponder the dedicated souls who stand as guardians of this frozen realm, we now turn our gaze to the meticulous work they undertake, the quiet vigilance that transforms the vast, silent continent into Earth's most profound laboratory. Their endeavours are not mere observations, they are a deep, patient conversation with a world that speaks in ice, wind, and ancient echoes. We embark now on a journey into the heart of Antarctic science, where every drill hole, every sensor reading, every shared meal in an isolated station contributes to a tapestry of knowledge vital for our planet's future. Imagine a library unlike any other, its volumes bound not in leather and paper, but in layers of compressed snow, stacked over hundreds of millennia. This is the profound reality of Antarctica's ice sheets, serving as Earth's most comprehensive climate archive. We delve into the practice of ice core drilling, a painstaking process that extracts cylindrical columns of ice, sometimes reaching depths of over 2 miles, piercing through epochs of geological time. Each layer, distinct as a tree ring, holds a pristine record of past atmospheric conditions. As we examine these translucent cylinders, we discover an intricate narrative. Tiny air bubbles trapped within the ice as snow compacted into glacial ice encapsulate ancient atmospheres. Scientists, with their keen instruments, analyze these frozen breaths, revealing the exact composition of the air from bygone eras, levels of carbon dioxide, methane, and other greenhouse gases that dictated Earth's climate cycles. We see, with startling clarity, how these concentrations fluctuated naturally over hundreds of thousands of years, and how dramatically they have surged in recent centuries, a stark testament to human impact. The ice cores whisper tales of immense volcanic eruptions marked by layers of ash and sulfate, and even cosmic events, recorded as subtle chemical signatures. They allow us to reconstruct past temperatures, precipitation patterns, and even the intensity of solar activity, offering an unparalleled understanding of Earth's climate variability and sensitivity. This is not just history, it is a vital Rosetta Stone for predicting our future. Our journey continues beneath the colossal ice sheets, into a world that defies conventional imagination. We have touched upon the existence of subglacial lakes, but let us now truly immerse ourselves in their mystery. Hundreds of these liquid oases, insulated by miles of overlying ice, exist in perpetual darkness and under immense pressure. Lake Vostok, the largest and most famous, is a prime example, a body of water isolated from the surface for millions of years. The very thought of such ancient isolation sparks a profound scientific curiosity. What life, if any, could have evolved in such extreme cut-off environments? The exploration of these subglacial realms is fraught with ethical and technical challenges. Scientists employ sterile drilling techniques, using hot water or specialized drills to penetrate the ice without contaminating these pristine ecosystems with surface microbes. The stakes are incredibly high. A single contamination event could irrevocably alter a unique, potentially alien biosphere. When samples are finally retrieved, they offer glimpses into microbial communities that have adapted to conditions of extreme cold, high pressure, and nutrient scarcity, thriving on chemosynthesis rather than photosynthesis. These discoveries expand our understanding of life's resilience and its potential to exist in environments previously thought uninhabitable, even offering analogues for astrobiological exploration on other icy moons in our solar system. Beyond the lakes, seismic surveys and radar penetrate the ice to reveal hidden mountain ranges and vast subglacial valleys, landscapes carved by ancient rivers and glaciers, now preserved in a state of suspended animation beneath the immense weight of the ice. Each new discovery beneath the frozen veil reshapes our understanding of Antarctic geology and its dynamic history. From the depths, we ascend to the pristine heights of Antarctica's atmosphere, a realm of unparalleled clarity and scientific significance. Here, high above the ice, scientists conduct critical atmospheric research, monitoring the very breath of our planet. The continent's remote location and minimal human interference make its atmosphere the cleanest on Earth, providing an invaluable baseline for understanding global atmospheric processes. Specialized instruments measure everything from trace gases and aerosols to cosmic rays and the dynamics of the ozone layer. You may recall the dramatic discovery of the ozone hole over Antarctica in the 1980s, a stark warning of humanity's impact on the global environment. Today, scientists at stations like the South Pole continue to meticulously monitor the ozone layer, tracking its slow but hopeful recovery thanks to international efforts to phase out ozone-depleting substances. This ongoing vigilance is crucial as the interplay between ozone depletion and climate change is complex and still unfolding. Beyond the ozone, researchers study atmospheric circulation patterns, crucial drivers of global weather systems, and the formation of polar stratospheric clouds, which play a role in both ozone depletion and climate feedback loops. The clear, dark Antarctic skies also make it an ideal location for astrophysics, with observatories like IceCube delving into the mysteries of neutrinos from distant galaxies. The air itself becomes a medium for discovery, revealing secrets of Earth's interconnected systems and the subtle shifts that echo across the globe. To truly appreciate the science conducted in Antarctica, one must also understand the human experience that underpins it. Life at the continent's numerous research stations is a testament to resilience, ingenuity, and international cooperation. Imagine spending months, sometimes a full year, in extreme isolation, surrounded by an unforgiving landscape, with temperatures plummeting far below zero and daylight cycles swinging from endless sun to perpetual twilight. These stations, from the bustling hub of McMurdo to the remote minimalist outposts, are crucibles of discovery. Here, scientists, engineers, and support staff form tight-knit communities, united by a shared purpose and an extraordinary environment. Daily routines are governed by the harsh realities of the continent. Meticulous planning for every field excursion, constant vigilance against sudden blizzards, and the careful management of every resource, from fresh water to fuel. The logistical challenges are immense, requiring specialized ice-strengthened ships, ski-equipped aircraft, and hardy over-snow vehicles to transport personnel and equipment across vast, treacherous distances. Yet, despite the formidable challenges, a unique camaraderie flourishes. Shared meals become forums for scientific discussion and personal connection. The isolation fosters a deep appreciation for human connection and a collective determination to overcome obstacles. International collaboration is not just a policy, it is the daily reality, with researchers from diverse nations working side by side, sharing data, expertise, and even a sense of humor. This spirit of cooperation, enshrined in the Antarctic Treaty, is perhaps one of the continent's most profound lessons for humanity, that in the face of shared global challenges, unity and shared scientific endeavor offer the most promising path forward. As we reflect on the myriad scientific pursuits unfolding across Antarctica, a singular, powerful message emerges. This continent, so vast and seemingly distant, is inextricably linked to the well-being of our entire planet, the data gathered from ice cores, subglacial explorations, atmospheric monitoring, and countless other projects are not mere academic curiosities. They are urgent dispatches from Earth's most sensitive barometer. The accelerating melt of the West Antarctic ice sheet, the warming of the Southern Ocean, the subtle shifts in marine ecosystems, these are not localized phenomena. They are echoes of tomorrow, portents of global sea level rise, altered ocean currents, and profound disruptions to climate patterns worldwide. Scientists, as the guardians of the ice, are providing us with the critical information needed to understand these changes, to predict their trajectory, and to inform the urgent actions required to mitigate their most severe impacts. Their work illuminates the delicate balance of our planetary systems and underscores the profound responsibility we bear. Antarctica's quiet wisdom calls upon us to listen, to learn, and to act. Its pristine landscapes, once viewed as merely remote and extreme, are now revealed as central to Earth's future, a testament to the interconnectedness of all life and all environments. We leave this chapter with a deepened appreciation for the dedicated minds who unravel its mysteries, and a renewed understanding of why this frozen continent holds such immense significance for every one of us, no matter how far removed from its icy shores we may be. The journey of discovery continues, inviting us to remain vigilant, curious, and ever mindful of the planet's silent, powerful heart. As we journey deeper into the heart of Antarctica, we find ourselves standing at the precipice of profound change, gazing upon a dynamic canvas where the ancient past meets an uncertain future. We have seen how this continent, seemingly immutable, is in fact a living, breathing component of our global ecosystem, intricately linked to humanity's well-being, demanding ongoing vigilance and international cooperation. The grand, silent narrative of ice and ocean continues to unfold, revealing mysteries that challenge our understanding and compel us towards deeper inquiry. The immense ice sheets, these colossal guardians of global sea levels, are not static monuments but intricate systems in constant, albeit often imperceptible, motion. We have touched upon the West Antarctic ice sheet, WAIS, and the colossal Thwaites Glacier, often dubbed the Quote 15, whose accelerating melt rates signal a critical phase in Antarctica's evolution. But the story extends beyond these prominent features, encompassing a vast network of ice streams and outlets, each responding to the subtle, yet powerful, whispers of a warming world. Consider the intricate dance of basal melt, a process where warmer ocean currents, subtly infiltrating beneath the floating ice shelves, erode the ice from below. Imagine these vast ice shelves, some the size of small countries, acting as buttresses, holding back the immense inland ice. As these buttresses thin and retreat, the inland ice, previously constrained, begins to accelerate its flow towards the ocean. This is where the concept of Tkersen Quote 16 comes into sharp focus, a hypothesis suggesting a potential runaway collapse once a certain tipping point is reached, driven by the geometry of the bedrock beneath the ice. If the bedrock slopes downward inland, as much of the West does, retreating ice exposes increasingly deeper ice to warmer ocean waters, creating a positive feedback loop that could lead to irreversible collapse. This is not a distant threat, but a process actively being monitored and modelled, a crucial piece of the puzzle we strive to understand. Beneath the glacial expanse, hidden from our direct gaze, lies another world, a complex hydrological system of subglacial rivers and lakes. These meltwater channels, formed by geothermal heat and pressure melting, act as lubricants, allowing the overlying ice to slide more rapidly over the bedrock. Imagine a vast hidden plumbing system, guiding meltwater from the interior to the coast, sometimes pooling into vast lakes like the enigmatic Lake Vostok, sometimes creating transient streams that surge and drain, influencing the pace and path of glacial flow. Our research reveals that these subglacial water systems can significantly impact the stability of ice sheets, making their mapping and understanding paramount to predicting future ice loss. We are developing techniques to peer through miles of ice, using radar and seismic waves to chart these hidden waterways and understand their dynamic role. The challenge, therefore, lies not just in observing the changes, but in predicting their trajectory. This brings us to the forefront of scientific ingenuity, where sophisticated tools become our eyes and ears in this remote realm. Satellite altimetry, like that provided by missions such as IceSat-2 and CryoSat-2, precisely measures changes in ice sheet height, revealing areas of thinning and thickening with incredible detail. Gravimetry satellites, such as GRACE-FO, Gravity Recovery and Climate Experiment Follow-On, detect minute changes in Earth's gravitational field caused by the movement of ice and water, allowing us to quantify the mass balance of the entire continent. These orbital sentinels provide a continent-wide perspective, charting the pulse of Antarctica from above. Yet the most critical insights often come from closer quarters. Autonomous underwater vehicles, AUVs, are our silent explorers, venturing beneath the vast, dark caverns of ice shelves where humans cannot go. Equipped with sonar, cameras, and oceanographic sensors, these robotic pioneers map the seafloor beneath the ice, measure ocean temperature and salinity, and observe the intricate processes of basal melt in real time. Imagine an AUV gliding silently through frigid waters, sending back vital data from a world unseen, helping us understand how warm ocean currents interact directly with the ice, creating channels and cavities that accelerate melting. These brave machines are pushing the boundaries of exploration, revealing the intimate details of ice-ocean interactions that are fundamental to our predictive models. On the surface, seismic imaging and radar sounding techniques allow us to construct three-dimensional maps of the bedrock beneath the ice, revealing the crucial topography that dictates ice flow and stability. By generating sound waves or radar pulses and analyzing their echoes, we can essentially X-ray the continent, unveiling hidden mountain ranges, deep valleys, and the intricate contours of the subglacial landscape. This detailed topographic information is indispensable for refining our ice sheet models, helping us understand where weaknesses might develop and how quickly ice might flow into the ocean. However, even with these advanced tools, predicting the future of Antarctica's ice sheets remains a formidable challenge. The complexity of ice physics, the variability of ocean currents, and the intricate feedback loops between ice, ocean, and atmosphere mean that climate models are constantly being refined. Scientists grapple with uncertainties, particularly regarding the speed at which marine ice cliff instability might manifest, and the precise timing of potential tipping points, thresholds beyond which ice sheet collapse becomes self-sustaining and irreversible. We are watching, learning, and striving to provide the clearest possible picture of Antarctica's future, a picture that holds profound implications for coastal communities worldwide. Beyond the ice, the Southern Ocean, the vibrant heart of Antarctica's ecosystem, faces its own set of challenges intricately linked to the melting continent. We've discussed ocean acidification, a silent threat caused by the absorption of excess atmospheric carbon dioxide. This process reduces the availability of carbonate ions, essential building blocks for the shells and skeletons of marine organisms. Imagine the delicate pteropods, often called sea butterflies, tiny shelled creatures that form a crucial link in the Southern Ocean food web. Their fragile shells are vulnerable to dissolving in increasingly acidic waters, threatening not only their survival, but the entire ecosystem that relies on them, from krill to whales. Furthermore, the influx of massive amounts of fresh water from melting ice sheets has profound implications for global ocean circulation. The Antarctic Circumpolar Current, ACC, the mighty river of the sea that encircles the continent, is a key driver of global ocean currents, regulating heat distribution across the planet. We know that the formation of deep ocean water, a process where cold, dense, salty water sinks near Antarctica, initiating a global conveyor belt, is sensitive to changes in salinity. As vast quantities of fresh water melt from the ice sheets, they can create a layer of less dense water at the surface, hindering the sinking of colder, saltier water. This freshening of the Southern Ocean could weaken the deep ocean water formation, potentially slowing down or altering the global thermohaline circulation. The ripple effects could be felt across the globe, influencing ocean productivity, marine ecosystems, and even regional weather patterns, underscoring the deep interconnectedness of our planet's systems. And then there is the ultimate frontier of discovery, the unique microbial life within the ancient subglacial lakes. Imagine Lake Vostok, sealed beneath miles of ice for millions of years, an ecosystem isolated from the surface world, potentially harboring life forms unlike anything we have ever encountered. The scientific excitement surrounding these hidden biomes is immense, offering a window into the limits of life and the potential for extremophile organisms to thrive in conditions previously thought impossible. The exploration of these lakes is not without its ethical considerations. We must proceed with the utmost care to avoid contaminating these pristine environments, ensuring that our quest for knowledge does not inadvertently destroy what we seek to discover. The techniques employed involve sterile drilling and sampling, a testament to the scientific community's commitment to responsible exploration. Unveiling the secrets of these subglacial worlds could revolutionize our understanding of evolution, adaptation, and even provide insights into the potential for life on other icy moons and planets. In this ongoing narrative of discovery, humanity's role is one of profound guardianship and relentless scientific inquiry. The Antarctic Treaty System, a beacon of international cooperation, continues to provide the framework for peace and shared scientific endeavour, demonstrating that nations can indeed set aside differences for the greater good of planetary understanding. Scientists from diverse backgrounds and nations work side by side, sharing data, expertise, and the challenging realities of life in this extreme environment. Their resilience, ingenuity, and camaraderie in the face of isolation embody the spirit of this unique continent. As we conclude this chapter, we are reminded that Antarctica is not merely a distant, frozen land. It is a vital, dynamic component of our Earth system, a silent barometer of global health. The unresolved mysteries, the precise timing of tipping points, the long-term effects of ocean acidification, the full implications of meltwater on global circulation, the secrets held within subglacial lakes, demand our continued vigilance and collective effort. We are called to listen to the quiet wisdom emanating from its vast ice sheets and vibrant waters, to understand its intricate processes, and to act as responsible stewards of this magnificent changing world. The journey of discovery continues, inviting us to contemplate not just the facts, but the profound responsibility that comes with knowledge. As we journey deeper into the heart of this frozen realm, past the known facts and into the shimmering mirage of what is yet to be fully understood, we arrive at the precipice of profound mystery. The previous chapters have unveiled Antarctica's unparalleled grandeur, its ancient secrets, and its vital role in the global climate system. Yet, beneath the vast, still surface of knowledge, a powerful current of unresolved questions continues to flow, pulling us into the unknown. These are not mere gaps in data, they are the very contours of our future, etched into the ice and whispered by the wind across the vast white expanse. We have touched upon the critical uncertainties surrounding Antarctica, but now we invite you to linger with us, to contemplate the true depth of these enigmas. Each unanswered question is a doorway to further discovery, a gentle challenge to our collective understanding. The colossal ice sheets of West Antarctica, particularly the Thwaites Glacier, stand as monuments to both immense power and delicate vulnerability. We know they are melting, their ancient bonds with the bedrock loosening under the insidious warmth of the ocean. What we do not yet grasp with absolute certainty is the precise timing and sequence of their potential collapse. The concept of tipping points here is not merely an academic term. It represents a threshold beyond which the retreat of ice becomes self-sustaining, irreversible on human timescales, regardless of our subsequent actions. Imagine a vast, silent domino effect playing out across thousands of years. The initial destabilization of one ice shelf, perhaps from basal melt, could expose inland ice to warmer waters, accelerating its flow. This, in turn, could trigger further collapse, an intricate dance of ice and water that we are only beginning to choreograph. Our scientific instruments, sophisticated as they are, peer into a complex system governed by myriad variables. The precise contours of the subglacial landscape, the geothermal heat flux from beneath the continent, the subtle shifts in ocean currents, and the ever-changing patterns of atmospheric warming. We strive to model these interactions to predict the future with greater accuracy, but the sheer scale and complexity defy simple answers. The implications of this uncertainty are immense, for the melting of these ice sheets could contribute significantly to global sea level rise, reshaping coastlines and impacting millions across the planet. The quiet wisdom of Antarctica demands that we listen, that we observe, and that we acknowledge the profound weight of this particular mystery. How quickly will the ice respond? Will we have enough time to adapt? These are the questions that echo across the icy plains carried on the Antarctic wind. Beneath the icy veil, a vibrant, intricate ecosystem thrives, fueled by the cold, nutrient-rich waters of the Southern Ocean. At its heart lies Antarctic krill, tiny crustaceans that form the vital base of the entire marine food web. We have learned of their abundance, their crucial role, but now we must confront the silent threat that looms over them and countless other organisms: ocean acidification. As our planet's oceans absorb increasing amounts of atmospheric carbon dioxide, their chemistry changes, becoming more acidic. This subtle shift has profound consequences, particularly for organisms that build shells or skeletons from calcium carbonate, such as pteropods, delicate free-swimming snails, also known as Quote 21, and the larval stages of krill. Their shells, once robust, become fragile, making them vulnerable to dissolution. Consider the ripple effect. If the krill populations decline due to acidification, what then happens to the whales, seals, and penguins that depend almost entirely on them for sustenance? The intricate balance, honed over millennia of evolution, could unravel with alarming speed. We are witnessing the potential for a fundamental restructuring of this pristine ecosystem, a shift whose long-term effects are still largely unknown. Will new, more resilient species emerge to fill the void, or will the biodiversity of the Southern Ocean diminish, leaving behind a less vibrant, less resilient marine world? The answers lie within the vast cold waters, a mystery unfolding in slow, silent motion beneath the waves. Antarctica, in its immense isolation, is deeply interconnected with the global ocean and climate system. We have seen how the Antarctic circumpolar current acts as a planetary girdle, isolating the continent. Now, we must consider another profound connection: the potential disruption of global ocean circulation patterns by vast influxes of fresh water from melting ice. The ocean's thermohaline circulation, often likened to a great global conveyor belt, is driven by differences in temperature, thermo, and salinity, haline. Cold, dense, salty water sinks in polar regions, driving deep ocean currents that transport heat, nutrients, and carbon around the world. Antarctica is a crucial birthplace for this deep ocean water formation. Imagine fresh water, lighter and less dense than salty ocean water, pouring off the continent's melting ice sheets and ice shelves. This influx could act like a cap, preventing the dense, salty water from sinking as efficiently as it once did. What would be the implications? Could this slow down or even alter the Great Ocean Conveyor Belt? Such a change could have far-reaching consequences for global climate patterns, affecting everything from regional temperatures and precipitation to the distribution of marine life and the ocean's capacity to absorb carbon dioxide. The precise magnitude and timing of these potential disruptions remain a significant mystery, a complex interplay of forces that continues to challenge our predictive models. Antarctica, in its quiet power, holds the key to understanding the very pulse of our planet. Perhaps the most tantalizing mystery lies hidden beneath miles of ice, the hundreds of subglacial lakes and interconnected river systems. We know they exist, preserved in isolation for millions of years, harboring conditions unlike anything found on the Earth's surface. Lake Vostok, vast and deep, has offered us glimpses of its ancient waters, but the true diversity of life within these hidden worlds remains largely unknown. What unique forms of microbial life have evolved in perpetual darkness, under immense pressure, sustained by chemosynthesis or geological energy? Could these ecosystems offer insights into the origins of life on Earth, or even provide analogues for potential extraterrestrial life on icy moons like Europa or Enceladus. The responsible exploration of these pristine environments presents both an unparalleled scientific opportunity and a profound ethical challenge. How do we sample these waters without introducing contamination from the surface, preserving their ancient integrity? The answers we seek could redefine our understanding of life itself, pushing the boundaries of what we deem possible. As we contemplate these profound mysteries, we are simultaneously drawn to the equally profound responsibility we bear toward this continent. Antarctica is more than a scientific laboratory or a barometer for global climate. It is a symbol of international cooperation, a testament to humanity's capacity for shared stewardship. The Antarctic Treaty System, established in 1959, stands as a beacon of peaceful collaboration in a world often fractured by geopolitical tensions. It designates the entire continent as a natural reserve, dedicated to peace and scientific research, explicitly forbidding military activity and holding national claims in abeyance. This unprecedented agreement is a living document, evolving with new protocols, such as the Protocol on Environmental Protection to the Antarctic Treaty, which designates Antarctica as a natural reserve devoted to peace and science. This spirit of cooperation is a fragile yet powerful force. It reminds us that even amidst the allure of discovery and the urgency of environmental monitoring, the fundamental principle of preservation must guide all our actions. We are not owners of Antarctica, but its temporary guardians tasked with ensuring its pristine nature for future generations, both human and non-human. The pursuit of knowledge in Antarctica is a noble endeavour, but it is one that demands meticulous care. Conducting scientific research in this fragile environment requires an acute awareness of our footprint. Every piece of equipment transported, every sample collected, every structure built carries the potential for impact. We learn to minimize waste, to prevent contamination, and to respect the delicate balance of the ecosystems we study. The scientific community operating under the treaty system exemplifies international collaboration, sharing data, resources, and insights across national boundaries. This collective approach is not just efficient, it is an ethical imperative, ensuring that the benefits of Antarctic science are shared by all, contributing to a global understanding of our planet. It is a quiet testament to the power of shared purpose, transcending individual ambitions for the greater good of knowledge and preservation. The awe-inspiring beauty of Antarctica draws an increasing number of visitors each year, seeking to witness its majesty firsthand. This growing interest presents a unique challenge: how to allow access to this pristine wilderness without compromising its integrity. Sustainable tourism in Antarctica is not merely about managing numbers. It is about fostering a deep respect for the environment. Operators adhere to strict guidelines, focusing on leave no trace principles, maintaining safe distances from wildlife, and educating visitors about the fragile nature of the continent. Every landing, every Zodiac cruise is carefully planned to minimize disturbance. The goal is to offer a transformative experience that inspires advocacy and stewardship, rather than leaving a lasting imprint on the landscape. We invite you to imagine standing on its shores, breathing its pure air, and understanding that your presence, however fleeting, carries with it a profound responsibility to protect what you witness. Ultimately, the mysteries of Antarctica and the challenges it faces converge into a powerful moral imperative for humanity. The data we collect, the changes we observe, and the predictions we make are not just scientific curiosities. They are urgent messages from the planet itself. Antarctica, in its quiet dignity, serves as a critical barometer for global climate health, reflecting the broader consequences of our actions on Earth. Our shared responsibility extends beyond the scientific community and the policymakers. It encompasses each of us as inhabitants of this interconnected world, understanding the facts, appreciating the delicate balance, and recognizing the global implications of Antarctic change empowers us to make conscious choices in our daily lives, to advocate for sustainable practices, and to support policies that prioritize planetary health. As we conclude this chapter, we are left with a sense of profound wonder and a gentle call to contemplation. Antarctica remains a continent of unparalleled beauty, a repository of ancient secrets, and a critical bellwether for our planet's future. The unresolved mysteries invite us to continue our journey of discovery, while the ethical frontiers remind us of our sacred duty to protect this extraordinary place. We have traversed vast ice sheets, plunged into hidden lakes, and soared above towering mountains. We have witnessed life's tenacious grip and the profound interconnectedness of all things. Now we invite you to carry this quiet wisdom forward, to become a part of the ongoing narrative of Antarctica's guardianship. For in understanding this distant, majestic land, we gain a deeper understanding of ourselves, our planet, and the shared future we are all creating. One fact, one contemplation, one mindful action at a time. The quiet grandeur of Antarctica awaits our continued reverence and protection. As our journey through Antarctica's profound mysteries unfolds, we find ourselves at a critical juncture, gazing upon the vast, shimmering expanse with a deeper understanding of its fragility and its monumental influence on our world. We have touched upon the unresolved enigmas that challenge our scientific frontiers, the accelerating pulse of the West Antarctic ice sheet, the silent threat of ocean acidification to its vibrant ecosystems, and the potential disruption of global ocean currents by the influx of fresh water. Now we turn our attention to the tireless efforts and ingenious methods employed by the global scientific community, an intricate dance of human ingenuity and Antarctic grandeur, all in pursuit of knowledge and the preservation of this frozen sentinel. To unravel the continent's most pressing secrets, we deploy an array of sophisticated instruments, each designed to pierce through the layers of ice, water, and atmosphere, revealing truths that would otherwise remain hidden. These tools are our extended senses, allowing us to monitor, measure, and model the subtle yet powerful transformations occurring across this immense white canvas. It is a testament to our collective curiosity, a global endeavour to listen to the whispers of a changing world. Imagine for a moment an orchestra of satellites silently orbiting high above, their gaze fixed upon the Earth's southernmost continent. These are our sentinels, providing an unparalleled vantage point for observing Antarctica's dynamic ice sheets. Missions like NASA's IceSat and the European Space Agency's Cryosat-2 utilize advanced laser and radar altimeters to measure the exact height of the ice surface with astonishing precision. Over time, repeated measurements reveal changes in elevation, allowing us to calculate how much ice is being lost or gained. When we speak of glaciers thinning or ice shelves retreating, it is often the meticulous data from these orbiting eyes that provides the foundational evidence. But the story doesn't end with elevation. The GRACE-FO, Gravity Recovery and Climate Experiment follow-on mission, offers another layer of insight. Instead of measuring height, GRACE-FO detects minuscule changes in Earth's gravitational field. When a massive amount of ice melts and its water flows into the ocean, the local gravitational pull slightly decreases. By precisely measuring these subtle shifts, GRACE-FO allows us to quantify the actual mass loss of the entire ice sheet, providing a direct measure of Antarctica's contribution to global sea level rise. These satellites are not merely data collectors. They are the silent chroniclers of one of Earth's most significant ongoing transformations, offering us a continuous real-time pulse of the continent's health. They allow us to witness the vast slow-motion drama of ice responding to a warming world, an unfolding epic visible only from the serene perspective of space. While satellites provide the grand overview, much of Antarctica's story is written beneath the surface, in the frigid, turbulent waters of the Southern Ocean and the dark, unexplored cavities beneath its ice shelves. Here, human access is often perilous or impossible. This is where autonomous underwater vehicles, AUVs, come into their own, sleek robotic explorers designed to brave the extreme conditions that would overwhelm human divers. These silent, intelligent machines are equipped with an array of sensors, sonar to map the hidden seafloor topography beneath colossal ice shelves, temperature and salinity probes to measure the ocean's properties, and cameras to capture images of marine life in these alien environments. AUVs can navigate for extended periods, mapping vast areas that were once entirely beyond our reach. They reveal the intricate channels carved by ocean currents into the underside of ice shelves, the pathways through which warmer waters can penetrate and accelerate basal melt. They document the health of krill populations and the presence of unique microbial communities clinging to life in the perpetual darkness. Imagine an AUV gliding silently beneath the Thwaites Glacier, its sensors meticulously charting the contours of the bedrock, feeling the subtle currents, and measuring the exact temperature of the water interacting with the ice. This direct observation is invaluable, providing critical data for refining our models of marine ice sheet instability and predicting future melt rates. These robotic pioneers are our eyes and hands in the most inaccessible and crucial marine frontiers of Antarctica, bravely venturing where no human can, bringing back vital pieces of the puzzle. Beyond the ocean and the ice surface, Antarctica holds secrets deep within its icy bulk and in the bedrock beneath. To probe these hidden realms, scientists employ techniques that utilize sound and electromagnetic waves. Seismic imaging, for instance, involves generating sound waves, often through controlled explosions or specialized vibrator trucks, and then listening to their echoes as they bounce off different layers within the ice and the underlying rock. Much like a medical ultrasound, these echoes create a detailed picture of the subglacial landscape, revealing mountains, valleys, and the presence of subglacial lakes and rivers, often thousands of feet beneath the surface. This allows us to map the precise contours of the bedrock, which is a critical factor in how ice sheets flow and respond to warming. Radar sounding offers a similar yet distinct capability. Here, radio waves are pulsed into the ice, and the reflections are analyzed, Different densities and compositions within the ice, as well as the transition from ice to water or rock, create distinct echoes. This technique is invaluable for determining ice thickness, identifying internal layers within the ice sheet, which can reveal past climate conditions, and crucially, detecting the presence of liquid water at the ice-bed interface or within subglacial lakes. Imagine a radar beam penetrating miles of ice, revealing the vast liquid expanse of Lake Vostok, or mapping the intricate network of subglacial hydrological systems that influence ice flow. These methods provide us with a three-dimensional understanding of Antarctica's hidden architecture, offering insights into its geological past and its dynamic present, allowing us to visualize the intricate dance between ice, water, and rock that shapes the continent. The data collected by this global network of satellites, autonomous vehicles, and geophysical instruments is not merely a collection of numbers. It is a symphony of information, each note contributing to a grander understanding. Scientists from around the world collaborate to interpret this data, transforming raw measurements into predictive models, comprehensive maps, and critical insights that help us decode Antarctica's future and, by extension, our own. The colossal Thwaites Glacier, often dubbed the Doomsday Glacier, stands as a stark symbol of Antarctica's vulnerability. Our advanced tools are particularly focused here. Satellite altimetry tracks its surface elevation changes, revealing rapid thinning. Gravimetry monitors its overall mass loss, confirming its substantial contribution to sea level rise. AUVs venture beneath its floating ice shelf, mapping the crucial interface where warmer ocean currents erode the ice from below, providing direct evidence of basal melt. Seismic imaging and radar sounding chart the bedrock beneath Thwaites, identifying critical. Quote 26. Underwater mountains that currently anchor the glacier, and revealing the retrograde slope of the bedrock, a geological feature that makes the glacier highly susceptible to marine ice sheet instability. By synthesizing all this data, scientists are creating increasingly sophisticated models that simulate the glacier's behavior. These models help us understand the complex interplay of ice dynamics, ocean warming, and bedrock topography, allowing us to project future melt scenarios and potential tipping points beyond which the glacier's collapse could become irreversible and rapid. This focused, multifaceted approach to understanding Thwaites is a microcosm of our broader efforts across West Antarctica, a testament to the urgency with which we are trying to comprehend and anticipate the behavior of these immense ice giants. The Southern Ocean, a vibrant cradle of life, is also a critical battleground against ocean acidification. Research vessels equipped with state-of-the-art laboratories traverse these frigid waters, deploying sensors and collecting water samples to measure pH levels, dissolved inorganic carbon, and other crucial chemical parameters. Fixed moorings and autonomous buoys are strategically placed to provide continuous, long-term monitoring of these chemical changes, acting as Quote 27 of the ocean's health. Scientists painstakingly analyze these samples, tracking the rate at which the ocean is absorbing excess atmospheric carbon dioxide and the resulting decrease in pH. They study the impact on foundational species like krill and pteropods, whose calcium carbonate shells are vulnerable to dissolving in more acidic waters. Laboratory experiments complement field observations, simulating future ocean conditions to understand how these organisms, and by extension the entire Antarctic food web, might adapt or succumb. The data gathered paints a sobering picture, highlighting the urgent need to mitigate carbon emissions to protect these delicate ecosystems. We are not just observing, we are striving to understand the ripple effects that could cascade through the entire global marine environment, underscoring the interconnectedness of all Earth systems. The melting of Antarctica's ice sheets releases massive quantities of fresh water into the Southern Ocean, a phenomenon with far-reaching implications for global ocean circulation. Oceanographers employ an array of sophisticated tools to study this interaction. Autonomous floats, equipped with sensors, drift with the currents, measuring temperature, salinity, and pressure at various depths, providing a three-dimensional view of the ocean's properties. Glider missions repeatedly traverse specific sections, building detailed profiles of the water column. These instruments help us track the pathways of meltwater and observe how it forms a less dense layer of the ocean surface. This stratification can hinder the formation of dense, cold, salty water that normally sinks to the abyss, driving the deep ocean limb of the air, quote 28, thermohaline circulation. Scientists use tracer chemicals and isotopic analyses to distinguish between meltwater and other sources of fresh water, allowing them to precisely quantify its volume and spread. By combining these observations with complex ocean circulation models, researchers are working to predict the magnitude and timing of potential disruptions to this global heat and nutrient distribution system. The implications are profound, potentially altering climate patterns across the globe, from tropical rainfall to polar ice formation. Understanding these dynamics is crucial, as Antarctica's freshwater outflow is a silent, powerful force reshaping the very currents that regulate our planet's climate. The scientific endeavours in Antarctica are not isolated acts of discovery. They are a profound expression of global cooperation, bound by the principles of the 1959 Antarctic Treaty System. This unique international agreement dedicates the continent to peace and scientific research, fostering an environment where nations collaborate rather than compete. Scientists from diverse backgrounds and nationalities work side by side at research stations, sharing resources, expertise, and a common goal to understand and protect this extraordinary continent. This collaborative spirit extends to the ethical dimensions of research. The pristine nature of Antarctica demands rigorous protocols to prevent contamination, especially when exploring sensitive environments like subglacial lakes. The moral imperative to conduct responsible research, minimize environmental impact, and prioritize conservation guides every expedition. As we venture into its depths, we carry the responsibility of stewardship, ensuring that our pursuit of knowledge does not inadvertently harm the very wonders we seek to understand. Antarctica stands as a critical barometer for global climate health, a testament to the planet's interconnectedness and a beacon for international cooperation. Our continued exploration, armed with ever more sophisticated tools and guided by a profound sense of responsibility, is not just about uncovering facts. It is about listening to the quiet wisdom of this frozen world, understanding its intricate systems, and taking action to safeguard its future, and by extension, the future of all life on Earth. The journey continues, inviting us to contemplate the profound beauty and vital importance of this last great wilderness.